Oh, um, so these are this is a varied thrush. I'll play a little bit of it in a second. This bird uses a lot of harmonics. In other words, it doesn't make a pure tone. It makes a tone, and then there's all these other tones kind of above it that give it a sort of substance. Extremely hard to hear. I mean, see. They're in dense forests, and this kind of sound actually, they're kind of like ventriloquists. So we're first going to look at neuroanatomy of song a little bit, and then the next thing we do will be chapter 12, which is kind of on neurons and the kind of neural stuff behind animal behavior. And, gender differences, all these different things. Ultimate causes. Okay. Okay. So obviously, I'm not sure exactly what the RA does, but there are songbirds and a few other taxa that can do that. There's these different nuclei that are kind of pathways where the song is actually produced. And then the syrinx, of course, is actually right here. In other words, goes signals down here. So the syrinx is a structure that it's kind of like our voice box, but it's much, much more complex than that, and much more capable of producing all sorts of different sounds, depending on the species. So here's the tracheal rings, the medial tympanic membrane, and you can look at this on your own to get a general idea of what's going on. So let's see, where's some nuclei? Oh, Iman, okay. So there's all these obviously pathways that are going on in terms of processing and making song happen. And then there's other parts, of course, song learning, which is obviously huge. If you're a songbird, you have to learn how to make the right song. And if you're a male, obviously, if you can't, song is usually on a signal. And if you're a female, you have to be able to recognize that's the song you want to pay attention to. Okay. So, as I said, you'd expect, since the male zebrafinch actually is the singer, and the RA is kind of essential for song production, that his is bigger than hers. Now, there are some species where the female and the male both sing equally as much, and under those circumstances, you would predict that the RA and all the other neural apparatus would be somewhat equivalent. Okay. Here's cardinal syrinx during singing. Showed it to you on the screen. It's a nice little X-ray of it. Hermit thrush. let's see, where is it? You can hear that. Thrushes are known for their different beautiful songs. So, the differences between the sexes, first of all, I talked a little bit about the heterogametic sex. And unlike mammals, birds, the heterogametic sex of the females, in other words, in mammals, females are XX, males are XY, and there's something called Haldane's rule, where males are more likely to show deleterious genetic mutations because if there's a mutation on the X chromosome, there isn't a corresponding X with males, there's just a Y that can't rescue it. And so for the most part, like reproductive isolating mechanisms, post-reproductive isolating mechanisms, a lot of times it's male inviability or sterility. Sometimes you can get actually a female that, you know, is not sterile. Like horses and donkeys mating and mules, depending on who's the mother and who's the father, in terms of the mule or the horse, the females are sometimes viable and fertile, but the males are never. So anyway, and in birds, it's the females that are ZW different, and so if there's a problem on the Z chromosome and it's on the W, there's no rescue effect. So you can actually see in, let's see, in this graph, at around 10 days, a lot of birds, that's the beginning of a critical period that often in songbird stretches from 10 to 50 days, but it's variable depending on the species. When birds are in fact primed to learn song, either the males learning to sing it or the females learning to recognize male song for when they're breeding later on. And here you can see days after hatching, there's an area for songbirds, and in males it's much larger, and it obviously develops much larger. And this all involves hormones being produced, and so they're produced differently in males and females. Right here, this is where hormonal influences during early development show some marked differences between young males and young females. So, estrogen, now, just so you know, estrogen and testosterone, of course, are associated, one with females, one with males, but oftentimes males and females are also exposed to the other sex hormone. I mean, just think about the spotted hyenas with a pseudopenis. The females are dominant over the males, and in fact, they get flooded with testosterone, and they start developing these male sexual characteristics, even though they're actually female. pseudopenis, pseudoscrotum, all that kind of stuff. Well, now when estrogen is actually implanted in newly hatched males and female zebras, finches, there's really no effect on males, but females develop larger song areas of the brain. Normal female, normal male, and then estrogen treated female. So, now, effects of testosterone vary depending on, obviously, there's elevated levels of testosterone for adult males. Females treated with estrogen when they're young do not sing as adults unless they receive testosterone implants, and then they do. And then females not treated with estrogen when young do not sing as adults, even if administered with testosterone implants. The females treated with estrogen as adults do not develop larger song areas of the brain. There appears to be a critical period around the time of hatching when the brain is sensitive to hormonal influences. As I showed earlier. Okay. Now, song nuclei in the brains of adult birds do change seasonally. They're obviously larger in spring, and in fact, there's a lot of different things that happen seasonally. For example, during the non-breeding season, a male's testes size is smaller, female ovary size is smaller. The song nuclei in males are smaller when not breeding than when breeding. And these effects are mediated by environmental cues such as day length, temperature, finding mates, and all that kind of stuff that would actually have changes like that. So photoperiod, as I just mentioned, directly affects this variation. Birds switch from short to long days, develop larger song nuclei. And then, of course, the amount of testosterone also affects the size. So, song learning are found only in a number of different groups of birds. The songbirds are passerines, right here. Some non-passerines like parrots and hummingbirds. But even in learned song, there's a strong gene by environment interaction. In other words, there are innate aspects as well as learned aspects, just like in human language. So with birds, there's usually songbirds, there's a species-specific template. In other words, kind of a template on what the song is. And then the birds have to be exposed to the song in a critical period, let's say from at day 10 or 12 or whatever, like hearing their father sing or hearing a recording, and that gets kind of crystallized with a male practicing over and over and over again onto the template until it's a perfect song. Now, there's a lot of birds, and if these birds are, let's say, raised in isolation, but they don't hear song during the critical period, they never do. Or even sing it properly. The songs of all other birds, of course, well, many are inherited. They don't have to hear song. They just naturally make the sounds they make. There are two different learning types. Age-limited or critical period song learners. These are often birds with a fixed repertoire, so they sing the same song over and over and over again. They have a restricted period of learning that occurs during the first weeks or months of life. And that's when they learn it. Now, I have to say though, white-crowned song sparrows or white-crowned sparrows actually show learning. They're called open-ended learners at times. So some populations of white crowns they don't move. They sing the same dialect, no matter where they are. That area-specific dialect. And then there's other populations that move, that migrate, and they actually can learn a new regional dialect when they get there. The critical periods vary greatly from one species to another and within species. So, okay. So here we are, day 1 to day 100 along the x-axis, and we have a critical period. The males are in blue. At the start of the critical period, they're listening to their father sing. It's overlaid onto the template. They start singing what's called subsong, where they practice it, get better and better and better. And then the end of the critical period, right there, let's say, they keep singing and practicing until the breeding season starts the next year around. Females also have to listen to their father sing, and they do. But they're not making song, but they have to recognize good song. And presumably, since Pop is breeding, he's a good father, and it's a good enough song that females respond to it. Let's see, let me go back here. Hold on.
No, we're on species that learn song, maybe classified into 2 types.
Okay.
Or that.
So, now, song learning is one of those things where it's both innate and learned. So there's an innate part, namely, there's kind of a song template for each species. And so, in other words, the birds are more likely inherently to kind of sing that kind of a song. And then there's a critical period. In other words, they have to be exposed at a certain time. And if they're not, normal song development doesn't take place. So, if a young birds develop in isolation, abnormal song. If a young bird is deaf, it's abnormal. Bird is deafened after it learned the song, it will still be able to sing normally. Young birds have to hear tutors, usually the adult males, their fathers, and they have to hear themselves singing against the backdrop of that kind of the father and the template. Let's see, did I, hold on one second. Okay, so I'm going to play normal white-crowned sparrow, and then one that's been isolated, and you can tell what it sounds like. So let's see here. No! Stop that!
I specifically lost my ideas to get a
Someone sent me a friend of mine.
Yeah. Well, also, mine was like back and forth like 6 more times. You'd probably be able to
Okay, now, this is what it sounds like for a bird that's been isolated. It's very simple and not right, okay?
So that's not right, you're saying?
Yeah.
Okay.
So the first one, that's much better, isn't it? Okay. So, sorry about that. So, anyway, this was normal in white-crowned sparrows. The first one was normal. If you go to the Moodle site, you can listen to it. The other one was a bird that was isolated, and so wasn't exposed to white-crowned sparrow song. Okay, so there's these different phases of development that generally happen. There's an acquisition phase where the song is learned, first by listening to it from a male bird, usually their father. And then the bird matches songs in the neighborhood to its own template. So if you actually put a bird, let's say, and it only listens to, let's say, a song sparrow instead of a white-crowned sparrow, it does try to sing a song sparrow, but it doesn't really do it very well. And then, but anyway, in the acquisition phase, then it begins to refine the template. So singing over and over, like learning a language or learning how to speak, training yourself over and over and over again. And then the song then is kind of retained in memory. So there's kind of a retrieval and production. Birds start producing their own songs and matching their songs to the template. So they actually sing what's called a sub-song. So it's not a full-blown adult song. And then feedback of vocalizations to template, that's the plastic song. So it's going to be changing. It's in a critical period. And because it's plastic, it means that it can change. And it gets refined and refined and refined and refined until the bird is actually singing a proper adult song. And then finally, there's this crystallization phase, which is the final adult song. Okay, and this is kind of a schematic of it. So here's the template. There's physiological factors, in other words, time period, usually daylight length, because this will be the start, well, this will be in the breeding season. There's a sensitive period, the auditory experience, in other words, they're listening to it. The template is modified by experience. It acquires this auditory template that starts changing. And then testosterone, vocalization, feedback from vocalizations, in other words, listening, singing, listening to oneself, singing. And then song is finally matched to the template. So that's the general structure of things. Okay, so usually there's a critical period from about 10 or 12 days to 50. But it varies by species, and it can even vary by individuals. Okay, so these are young birds. In other words, if they don't learn song by, let's say, age 50, they will never sing it properly. kind of what happens with humans. You know, they've done these things. They've found, I guess, kids who were locked in the basement. They never heard talking, and they really never learned how to talk properly. So that's when it
It
is.
says 10 to 50, but what if it's before 10?
What?
What if it's before 10? Does it happen at past 10 or
Um,
they 10, like maybe they're even still in the 8?
I don't think so. I'm not sure. I don't know. But I know that usually there's a specific time period that's kind of the critical period. Oh, okay. Let me see. So here's a song sparrow. Here's a white-crowned sparrow. Let me see something. Okay.
That's probably the only reason why I call it the camera. Then I can take good selfies in it.
I'm just glad it actually works.
Yeah.
I'm like, no.
I'm taking a quiz.
Okay. Okay, now, let's see here. Oh, that's that again. Okay, so this is normal song. Come on. And this is isolation song. And then go on. Okay. So So that's the same white-crowned sparrow, and here's. Okay, that's good. Stop that.
I don't see the difference, but
No. It's not happening yet. Hold on.
I knew about like a Halloween party a few weeks before. Like that.
God damn it! Come on.
that's so weird. That's so weird. How does it affect the process?
I feel like if it's open salon, let's do it. And I feel like I'm gonna have USC, I'm not gonna have like, because Western has a block system. You take one class, and then you take the exam on it, you take another one. It's not like 15 out of 10.
Combined? Yeah. So the SC's all combined classes?
Yeah, it's insane.
Yeah, that's like setting you up for failure, man.
So like I keep talking to Western, like going to her. She goes back to salon. I don't know what to say.
God. Come
They guys
on.
get the same degrees, right? whether it's SD or Western?
I do nine lessons.
Huh? It's the brand.
Okay, I give up. So, sorry, I can't get to work. Anyway, what happens is, when this bird is raised with a song sparrow song, so this is what it actually sounds like. This is what the sonogram looks like for a song sparrow. Here it is for a white-crowned. You've been hearing white-crowned. There's this neural template, which is kind of the open period where they can learn. And then songs develop plastic and full song, and the matching phase. And so what it actually does is it kind of incorporates over its own template what it's been hearing. So it's not actually producing the right kind of song. So a lot of the work this has been going on for a long time. This guy Thorpe, he was a British fellow. He was raised raising chaffinches, probably in, I guess he was probably in England or maybe Germany, I don't know. And he had these chambers where they could not hear the song of their parents, and he found that they could produce only a rough song. So that's the kind of innate template. He also showed, of course, that there was the sensitive period. So after these birds were kept in isolation, they were exposed to the songs of chaffinches and other species of finches. He found these birds could learn songs for the first 13 months of life, but not after. Furthermore, naive birds would selectively sing chaffinch songs rather than the songs of other species.
He has a question over there.
No! What?
Does that relate to, like, if a kid learns a language when they're young,
Mm-hmm.
and they won't have an accent, but when they learn a
What
language,
do you mean they won't have an accent?
like kids who like know Spanish, and, like let's say they learn English when they're 3,
Yeah?
and then they learn Spanish when they're 5, and they learn Japanese when they're 7.
Yeah.
They're not gonna have an accent. They're not gonna have like a.
They're going to have an accent of what they hear. Like if they're hearing British English, they're going to have British accent, right?
But past a certain age, like let's say I were to learn Spanish right now.
Yeah.
I have like a terrible accent.
Right.
But if I learned Spanish when I was like 6, 7, I wouldn't
Yeah.
have an accent in Spanish.
No. You would, but it wouldn't be like. First of all,
Would it be a Gringo accent?
yeah, okay, so in terms of language, little kids, especially really young kids, can learn a whole bunch of languages all at once. They don't have any trouble figuring out, mixing things up or anything like that. And then over time, if they keep learning all those languages, those languages will finally be kind of there for them. Doesn't mean they don't keep learning new words and all that kind of stuff. So that's why when you bring you have a kid and you go to another country, they usually pick up the new language right away, while you look like a doofus, right? Now I will say that there's individual variation. I know some adults who are just plain amazing at learning new languages. It's like nothing's really changed for them. I knew this guy, he speaks like 14 different languages. And it just makes sense to him. When he hears a new language, it just makes sense. And he starts putting things together, and within a month he's speaking. So, but that's not the most of us. Most of us, it's a grind. So, but in the same way, songs are learned in the sensitive phase. There's also dialects that we'll get to, but different populations of birds will often sing different dialect. And we'll hear that in a little tiny bit. Let's see here. Okay. So, in white crowns, there was a sensitive period between 10 and 50 days for these kinds of birds. Other birds are slightly different, but early on in their lives. After 50 days, learning could still take place in about 70% of the birds if a live bird was used as the father, right? The idea of social stimulation is important. Live birds are important. In other words, they often interact with a live bird where just recording is not the same thing. So, and this is especially important, social environments in birds are really, well, like a lot of different species, they're huge. And in certain social situations, you learn certain things like, I think there was something, we'll get to it probably with brown-headed cowbirds, but the females, if they don't hear the right thing, and then they don't respond, and so the males actually have to learn how the females like it. Okay. Oh, so white-crowned sparrows exposed to live tutors, in other words, live birds, extend their critical period basically beyond 50 days. And this work was done by Luis Baptista and Petranovich. Luis could actually sing, whistle, all these different dialects of white-crowned sparrows. He just had one of those minds where it's kind of like he could mimic. He died, I don't know, 10 years ago, but he was amazing. He was from Macau, and he was just incredible in terms of his natural ear for birdsong. So, one of the advantages, I guess, of having a sensitive period is that there's a premium on age of first breeding. So, in other words, you better learn the song early because then you'll be ready to breed. Otherwise, you'll get left out of the fun. So, age of first breeding, and they're usually found in a harsh desert environment. There's a sensitive phase that ends at 14 weeks, and that's pretty much it. Now, there's also, so this is, the one before was they have a certain period of time to learn the song, and then that's it. The song is crystallized, it doesn't change. Now, there are some birds that have open-ended learning. They can continue to update their songs. This is especially important if they end up traveling and encountering birds that sing a different dialect. Okay, so they learn from new neighbors, aids in male-male competition, so they learn new songs throughout their life, and of course, they learn the correct song for the population that they, let's say, meet in terms of what the female likes. So there can be quite a bit of variation in the actual dialects that they're singing. So, let me see if I can get that to go.
Sounds so pretty.
Okay, so that's a brown-headed cowbird.
That was a bird.
And these guys are brood parasites. In other words, they come in, they lay their own eggs in someone else's nests. They get the other birds to actually raise their brood instead of putting in all the effort. And usually their own offspring grow more quickly than the host. So now you have to remember, brown-headed cowbirds, they don't ever hear their father sing, right? They're only hearing their adoptive parents sing. So they actually have a delayed song learning period where they finally encounter what a normal cowbird song sounds like. And then so when, like in yearlings, it's just pretty poorly developed, but it gets better and better over time. So, male cowbirds that have never heard other cowbird songs produce correct cowbird song. In other words, it's kind of an innate thing. They can do natural song because they're not really going to learn it from their father. Now, the songs of cowbirds are shaped by male-male interactions and by female responses to the song. And so, isolated as males sing more potent songs than young males raised in a social setting. Why? So let's see. Males that do not have visual or direct contact with dominant males produce more potent song than do males. Okay. Then young males learn to modify their songs to avoid, attack. Okay, that's right. So if in a social setting, they don't sing young birds at the top of their lungs because that is likely to induce an attack from a more mature male. So they sing, but they don't sing like they would if they were all by themselves, where they're just singing out. They modify it depending on who's around them at that time. So let's see, percentage of songs that release the copulatory posture of females. Okay, auditory and visual isolation. Visual, so rearing condition of males with respect to male conspecifics. Okay, visual isolation, visual contact, direct contact. So I guess they need auditory and visual isolation. I'm not sure what that means. Then young. Oh, okay. Well, on we go. Sorry. What they were doing. Oh. So, female influence. Male cowbirds modify their song in response to female display of a wing stroke. So the females do this little display. The females only display the wing stroke discriminately, only to some males and not to others. And males change their songs to solicit a female's display. So if she doesn't get the right song, then she's not going to give the wing flick, and the poor male's going to be, feeling like left out. But if he then starts producing a variation on that song, and he perhaps gets it right, then the female actually will give him the wing stroke and the wing flick, and then perhaps copulate with him. Okay, so let's see here. Yeah. Here's now, like I mentioned earlier, there aren't very many birds. There's songbirds, which are the passerines that learn songs and have, a highly varied song. And then there's also hummingbirds sing a song, like songbirds do, and then parrots also do the same sort of thing. Now, let's see. Vocal non-learners, in other words, they're born with it. And then learners, they learn what their proper song or call is. They've looked at the brains of all these different species. Are somewhat different, but still using some of the same structures. So parrots and passerine songbirds have much more in common in terms of the song nuclei in their brains. So, obviously, song is for who, in general?
The one that's
Female.
Female. And who else?
So, males?
Yeah. So, other males. A lot of birds actually establish territories with their songs. And so, instead of hearing a territory holder over there and responding with a big attack, what they do is they get used to it. Oh, that's Harold over there. I don't have to go and attack him. He's got his territory, I got mine. Maybe his wife will come over for a little couple of extra pair of copulations. Who knows, right? So now a male can fine-tune a song in terms of the transmission characteristics. Let's say they live in slightly different habitats, and certain habitats, let's say you've got a forest habitat, you have a bird that's found widely, and in some places there's a forest habitat, in others there's an open woodland. Song carries in those situations differently. And so it's been shown that young males can actually change the way their song is depending on what habitat they're in. Of course, there's territorial defense. And then song learning may have evolved as a means of transferring complex patterns of behavior from one generation to the next. This hypothesis predicts that more information can be stored in memory than in genes, especially in terms of how to respond properly in a social context. It also may, there's this idea that it's a mechanism to identify your species, and not only that, but the population from which you belong.
I had it at maybe that's not so much a discussion question about art. But I just good job.
Today was like a legit for an update, that's hilarious. January. We were on it, dude. We were on it.
We were about to get that.
We were there for the 16.
Oh, no, I didn't try.
When you guys added the
Let me check. Are you trying to add that class?
Oh, I know.
No, but
Is this bird song?
I think this is where we left off about dialects. And, oh, it was, that's right, hayseed. Right? A hayseed. Okay. Okay, so, birds have dialects too. And they look down on other dialects, like we do. And, so, dialects are kind of like a sign of being in part of the in-group or the out-group. There's even sub-dialects, like like if around here, if you're a surfer dude, gnarly man, rad, tubular. Well, that's how we used to say it back then. I don't know what they say now. Anybody in here surf?
She does.
She does.
Okay, so what's the dialects now? Anything tubular?
No, definitely no tubular, but there's a lot of cool bro.
Cool bro? Oh, cool bro. Okay, yeah. That's too soon. Anything else? What happens if it's a gnarly big day?
And we say that ironically, but nobody says it genuinely.
Okay. So in other words, no time to like cry for your mama when it's too big. Oh, okay. Because I've done that.
300 years ago.
It was big. Triple overhead. Okay. Let's see. So dialects are the same way with birds. Yeah. Tasty. Okay. Hey, say. Okay. So, maybe everybody should try their own. So no, we can't. That's really mean, isn't it? It is. I'm sorry. Anybody in here is from the South?
I used to live in Atlanta, but not originally from Atlanta.
Yeah. No, you don't look like a Southern girl. I'm sorry.
I don't either.
Okay. So, I think right now that's where we're going to stop so that I can meet with people who are actually doing topics instead of doing a field project. Okay? So, get with your groups, and then I'll come around and talk to you. And then let's see if I can...
Why you lose your mind?
So here we have white-crowned sparrow from California, from Oregon, and from Canada. Okay. So you can hear the difference between California and Oregon. And then finally, that's Canada. So, here's the basic structure is a whistle, trill, and a buzz. This is Marin County, right near San Francisco. This is Berkeley, and this is Sunset Beach. And within these three areas, each one has a different dialect. Talking about provincial, I mean, they're really provincial. So, a lot of this work was done by this guy named Luis Bautista, who was originally from Macau, who had just an amazing ear. So he could pretty much do any song dialect for white-crowned sparrows and all these other birds as well. He's phenomenal.
Question. So what happens if you take, they're all the same species,
from one area to the other area because they learn dialect?
Well, during what period of the newborn? Right away?
Before, yeah, right away.
Before the
the
critical
10,
period.
Right, before the critical period.
Well, they'll learn the new dialect. Pretty much. Now, the thing is, there's some populations that don't, they're resident year-round, right? So they just learn one dialect and that's it. But there's a lot of others that migrate, and they're likely to come across other dialects. And they actually have to learn the new dialect.
So they're able to.
Yeah, because if they don't, they'll never get any matings.
So what happens to the whole critical period? The whole critical period is just to learn how to speak the language.
Pretty much, yeah. So there, there's these open-ended learners, and then the ones that are these white crowned sparrows are kind of in between. Okay, they're not really. There's some open-ended learners like oh God, I guess indigo buntings and stuff, where they really just learn all the way through. These guys, it's more restricted, but they can still learn new dialects. And if they don't, obviously, it's you can see how that could lead to population isolation and things like that. So, I talked to you a little bit about habitat structure and how different sounds work in different habitats. So, you've been in different habitats. So you've been in rooms that are really bright, let's say a club or something, and you can't, they're not really designed for you to talk to the person you went there with. They're usually there, you're listening to music, it's really bright, you can't understand anything that's going on. In fact, you might even revert perhaps to a sign language, if you could speak it, because you'd have a better conversation. There's other areas, other rooms where it's really damped down and you can understand things easily. Well, the same thing happens in different habitats as far as the way certain sounds carry in different habitats. So, except for Dumbo, who flew, we're not really talking about elephants here, but we will. Elephants communicate with these really, really low sounds that travel a long way. They don't use high sounds. It turns out high sounds in open areas kind of lose their punch over a shorter period or a shorter distance. So elephants can actually communicate with these very low rumbles over kilometers. Well, the same thing happens with birds, and certain birds use certain sounds. Are you gonna sneeze? Okay, Gesundheit. Either that or you're going, oh, okay, come on, get with it. Okay, so simple tones. Well, these travel further. Simple tones are better for dense habitats. Complex songs with a lot of temporal structure changes over time work well in open habitats. So there's all sorts of different things that are going on. Now, depending on who the receiver is, sometimes the sound obviously doesn't have to travel very far. So we were looking at those birds of paradise that have all these amazing kind of courtship rituals that include visual as well as sound. And as far as the sound goes, the female's right there. Now, of course, he has to call her in, but most of the auditory signal is right there. So it's not like it has to travel very far. So it depends on what it's being used for as well. Let's see. Okay, so these are. This is a great tit. We have similar things like mountain chickadees and black-capped chickadees here. This is one of the ones found in Europe. A lot of work has been done. And they're found all over the place, as you can see, from Sweden, Norway, England, Spain, Iran, Morocco, all over the place. And they actually have different sounds for different habitats. Gonna work? No? Okay. Excuse me. Okay, let's see. Great hits. I'll find it. I got it somewhere. Okay. Sorry. Okay, I'm gonna have to get online. Well, okay, I can't seem to find it, so forget it. Anyway, they do sound different. If you actually look at the sonograms, you have these kind of more constant tones. They look a little bit, let me see what it says here. Frequency, right. So, dense forests are more similar in all the dense forests, and then in our more open woodlands where song carries further, there's a lot more complexity to their actual song. So, as I mentioned, one of the things that that song is for, as a signal, is territorial defense. So songs are usually for territorial defense and courtship, primarily. And then there's other things that birds do, like they do calls, calls that are kind of like warning calls and things like that that sound different, and that both genders do. So, song and territorial defense. A defender of a territory obviously has to maintain that defense, and a lot of what the song actually does is impart information about his quality. So if he's not making a very good song, well, he probably doesn't even have a territory for that matter. But the song will also tell you the size of the territory, the quality, how long that bird has been on that territory. In fact, some birds, it's kind of a dominance hierarchy, and they may have held territories each year with a different female over a number of years. And then, of course, if there's adjacent territories, there's no sense fighting your neighbors. You already know who they are. They already know who you are. And so you can say, oh, that's Harold over there. And then if someone else sings that's not part of that group, they'll get attacked and driven away. At the same time, there's also some birds that don't want to be found out. They don't have territories. They're floaters. And they're male floaters that are looking for any stray females they can find, or females that are on another male's territory. So it's a kind of a different strategy than if you're a territory holder. Now, usually it's more like making the best of a bad world in that situation. So, oh yeah, let's see if I can get that working again. Okay. So they've done this with we do a lot with a lot of song stuff. We do playbacks and controls. So a control would be, let's say, a different song from another bird or something like that. But in this, this is the mean number of intrusions per hour from, let's say, rivals. And obviously, there's a huge difference in terms of what the song is actually preventing here.
If you hear a bird song you can't identify, the chances are it's a great tit. The males have an astonishing variety of calls and songs, which they use at different places in their
I
territories,
know, okay.
probably to persuade rivals that there's more than one bird about. The songs are usually simple, metallic sounding, and often very loud and persistent, and they still manage to fool me sometimes.
I know, it's funny. I agree. Okay. So, this is what they did was they actually, I know, all you can think of is great tit, great tit, great tit, great tit. You're not thinking of that? Oh, okay, good.
You should have a gutter.
What?
Nothing.
Gutter? Oh, okay. So, it's that you actually can, because of the sound thing, these songs, you can actually map out territories. And I've done a lot of that in the past. And you just walk around and you hear where different males are singing, and you kind of plot it. And so these are a bunch of different territories that are occupied on the left. And then here's the experimental setup. So the experimental, the control sound, control silent. And then territories occupied after the removal. So let's see. So these are different different territories, both of these. And it actually shows what's happened in various places after things have been occupied. So once the territorial males have been removed, within a short period of time, other males move in and set up their own territories. Some of those might just be other males that have already adjacent to that expand their territories, or other males that were initially driven out. And they use two different kind of controls, a penny whistle and then silent. And then, yeah. So obviously those with the speakers kept other males away. So it's obviously a first line of defense. Keep other males away from your territory, but also to establish that your territory boundaries are kind of sacrosanct in terms of other territory holders. Okay, so this is kind of a schematic. Here's a focal bird, a neighbor, and a focal bird. So beginning and then aggressive responses. So if it sings and it sings a type match, this neighbor, then it'll stay the same type and responds aggressively. Or it'll switch to a different type of song. If there just sings a song repertoire match, which is closer, it'll sing the same type match, or it'll switch to a different one. And then if it sings an unshared song, not much happens. So it really depends on how the neighbor responds and what then happens with the focal bird again. So obviously, if it sings the same type but not the same repertoire, it'll get an aggressive response for the most part. So there's a lot of intra-variation in some songs. Like brown thrasher, they're part of what a family called the Mimidae. Sounds like mimics. And mockingbirds are one of them. All the different thrashers, catbird, all kinds of different birds. And they have pretty varied songs. So, pretty varied. It turns out, in terms of repertoire size, so you can see a whole bunch of differences here. An Eastern Towhee, they sing the basic song, but they might maybe have a repertoire size of, pretty low, less than 10. And then what they do is for each repertoire, they do 10 to 30 copies, and then they switch. Now, song sparrows about the same. Marsh wrens are notorious for having varied song repertoires. Mockingbirds, well, you've heard them around here. They not only have a repertoire of, let's say, their own kind of song, but they mimic everything. Barking dogs, hawks, all kinds of different things. And as they get older and older, their kind of repertoire goes up in size. And then brown thrasher, over 2,000. In fact, actually, I don't know exactly how they kept track of each one, but I guess they did. There's another bird in Australia called the lyrebird. That's from this group that's rather extraordinary. I think I have something with it here. If not, I'll find it. Okay. I'll get back to the lyrebird in a bit. So, here's a song sparrow, the full repertoire size, and territory tenure. So, here, let's see here. So, tenure means the number of months it's been on a territory. And then here's a full repertory size and half-hour repertory size. And then, let's see, number of shared songs and repertory size. Okay, so this is a song sparrow, common bird from around here. Not doing it. Okay, might be able to find it here. Mhm. Okay. Hmm. Hmm. Sorry. Come on. Let me see something. Oh, that's great. God damn. What the hell's a song sparrow? I don't know. I can't. Let me go online. Be easier. No, that's not what I want. Okay, keep going. Okay. Okay. So, getting back to this, number of shared songs and the territory. Um, there's both a positive correlation with both. Number of shared songs and song repertoire size. And, of course, how long a territory is actually held. So, obviously, with a song sparrow, if they can have a larger repertoire size and the number of shared songs, it kind of shows that they're a bird that's been around, that's had time to acquire all these different repertoires by practicing them, versus a young bird who probably has a much lower capacity. So, birds obviously, a lot of them use plumage to attract mates. And having, let's say, a bright plumage, it's an honest signal. It might make the male bird more prone to getting eaten. So a bird of high quality can afford that handicap. Well, the same thing goes with songs, or like with frogs croaking. the more they do it, the better it shows that they have more endurance, better quality. And so part of it is the vigorousness or frequency of singing. So if some bird gets pooped out after a short period of time, that's a pretty good measure of low quality. The speed of delivery, the length, the repertoire, in other words, the number of different songs that they sing or different variations. And of course, females prefer more frequent singing, longer songs, none of this quick stuff, a fast delivery, and large repertoires. In other words, they get bored if you're singing the same boring song over and over and over again. They want to be entertained. Okay. Okay, let me switch this out so we can actually see this. Okay, I guess I gotta do this. So, if we actually look at this, let's see, days, it says days until, days until first egg. So, what's happening here is that in the beginning, when they're courting and copulating, the females prefer a really complex song. But once she's producing eggs, the repertoire size goes down. You know, that's pretty much, oh, this is my hubby, I don't have to go, and the hubby doesn't have to say, oh, I don't have to go attract a whole bunch of females now, she's mine. Let's go back to here. The song quality, obviously, energy reserves, perhaps the strength of the immune system, level of stress or deprivation. So if, as you're growing up, if you don't have enough resources, it's likely to have a big effect on the size of the song nuclei in the brain. In other words, perhaps the kinds of songs and the repertoire size that an individual male can produce. And then it's actually maybe easier to assess male territory by song in terms of quality than by, let's say, his plumage. Obviously, song travels much further than a visual. So visual might be for one thing, and song, in terms of territory, is for another. Okay. So, let's see here. Okay. Here's a tape tutor, a good copy, tape tutor song, a poor copy. So this is a song sparrow. Mean number of displays. Obviously, good copies do much better than poor copies. So this is what it looks like in terms of the tutor. This is what it looks like in terms of the poor. And then here, there's a pretty good fidelity of what actually is being done in terms of song sparrow male quality. Okay, so winter wrens, if you want to see a winter wren, you can go up to the Pacific Northwest. They probably have the most amazing repertoire size of any bird I've ever heard. And they're the smallest wren in North America. They're really tiny. They're not much to look at, as you can see here. But they make this incredible, I don't know how they just don't completely run out of juice when they're singing it.
Track 8, Winter Wren Song at Normal Speed.
Not very loud. Okay, we'll go back to it. Hold on, let's see here.
Track 8, Winter Wren Song at Normal Speed.
Not a very good track.
Winter Wren Song, 1/2 normal speed.
Hold on, too loud, I know. I'm going to take care of that.
Track 8, Winter Wren Song at normal speed.
I wish I could get it. God, pain in the butt.
Winter Wren Song, 1/2 normal speed.
Is that better?
Winter Wren Song, 1/4 normal speed.
Okay. Okay, so there are some instances where the males and females both sing to each other. And they're duets. So they have these highly coordinated songs that they do where it almost sounds like, it's actually two birds, but it almost sounds like the same bird, but one is picking up the rest of the song. And there's a number of different hypotheses. So one is if they're on a territory and they're spread far apart, it's kind of an acoustic contact. So they can keep track of each other. Obviously, territory defense hypothesis. Pair bonding, in other words, part of the courtship display where they sing, they counter sing. You know, if two people can make a beautiful song together, it's better than just one guy sitting underneath the balcony singing away, right? And then mate guarding hypothesis. So, in other words, if there's another female, let's say, that comes on the territory, the male gets his female to sing to show that, oh, she's taken, and tells the intruder to go away, even though the male may actually want the intruder too. Oh, hold on. There's something, I guess can't get it to do it. Here. Hmm. Yeah. So what they do is they sing back and forth, essentially. Now, there's also some birds that apparently sing a victory song. They go to battle, and then what they did was they tested with these playbacks, simulating like a territorial dispute. And the 16 pairs, they won 16 and lost 2. Only the pairs that won sang a victory song. And Victory Song was distinctive. It was louder, longer, and sung from a higher perch. So it's kind of like going into battle. You win. The winning side has a fife and drum and all that, and they're playing loudly like they won, because the losing side probably the fife and drum of the losing side, well, they're all dead, so they can't really play a victory song. Okay.
How do you think the bird knows which songs to sing?
What?
How do you think the birds know, like, how do they know, how do they learn the different songs?
Oh, you mean all these various repertoire sizes, or what? Or the
You
victory
have like
song,
a
or?
victory song, and then you have like a duet, and then you
I
have
don't know.
a main song, and then you have, it's like a language, right?
Yeah.
So how do they know, when to use what?
I don't know if they hear it.
How do they learn that?
Yeah. I'm not sure. I don't think these birds have a critical period. So I think they can learn it, and perhaps when they get older, and I think there's also, they have territories, there's probably a number of birds in them. But I'm not really sure, to tell you the truth. I don't know. Whether there's an innate template, or whether there's actually something that they learn and develop. Of course, if they're always losers, they don't have to learn it. Right, so. Okay, we've heard, so let's go on. So, there's also mimicry. Interspecific territory defense, so obviously within the same species, mate choice, larger mimic repertoire, like the thick-billed euphonia mimics other species' mobbing calls. This is especially common when they're dealing with, let's say, a predator, like an owl. I've seen owls owls get it terribly. When an owl is found out during the daytime, a lot of times all these birds that are normally not found together, all different kinds of species, all of a sudden convene on this owl and go to town on them. So they're singing, they're diving in, pecking on its head, all sorts of different things. And then Steller's jays mimic red-tailed hawks. So if you want to go up to higher mountains, whether it's Steller's jays around here, oftentimes you'll just hear this song that's actually just a mimic of a red-tailed hawk. Let's see. Oh, here we go. It's not doing it. Damn. Again. Okay. I'll see if I can find one. So that's something else. So that's a red-tailed hawk call.
You speak their
And
language.
what?
You speak their language.
I do. I know. But they don't really listen to me, unfortunately, so I don't speak it well enough.
Why is it making that call?
Oh, I think it's probably in terms of an effect on other birds. So they think, if they don't see it, they think, oh, there's a hawk here coming in, so it's dangerous, so they should take off. Or it could be that there is a hawk and it's saying, get out of here, this is my territory. So, and it's pretty realistic. I mean, I've been outside and, you know, I hear red-tailed hawk right next door, and there's no red-tailed hawk anywhere. And then I see there's a Steller's jay, you know, making a red-tailed hawk call.
Maybe just cranky.
Well, it could be. I mean, they're smart birds. They're corvids, right? They're crows, ravens, all that. So they're pretty, yeah, franks, pretty much. So there's other kinds of vocalizations with birds that both genders make besides song. They're usually simple sounds. They're contact calls between a male and a female. There's distress calls. There's alarm calls, letting other birds around know that something's dangerous. There's, of course, begging calls and flight calls as well. Okay, I don't know if I had something in here or not. Doesn't look like it. So here's drumming. Oh, hold on. Let me turn that down.
This is bird note. Like a jazz player beating out a drum roll, a woodpecker uses its bill to rap out a brisk series of notes. Early spring resounds with the percussive hammering of woodpeckers. Their rhythmic drumming works like many birds' songs. It broadcasts to other woodpeckers over a long distance a clear assertion of territorial and mating rights. We also hear woodpeckers knocking on wood when they're carving holes in trees to create nest cavities or extract insect prey. But these whacks are more methodical. Woodpeckers in the West offer a fascinating cast of different drummers. A hefty pileated woodpecker lets go a resounding tattoo against a hollow trunk. A red-breasted sapsucker seems to be signaling in Morse code as it snaps its bill against a stub of dead branch. And a Williamson sapsucker bangs out a triple drum roll. For any woodpecker, it's all about proclaiming a sound signal as far and as loud as possible. And as it searches for the most resonant drum, it might just find that your metal rain gutter makes the best music. For Bird Note, I'm Michael Stein.
Okay, let's see here. Okay, let's see here. I'll find it. I guess I can't. Oh, God damn it.
Track 13, ruffed grouse drumming.
You know what it sounds like? You know when you drop a ball and then
How do they learn to do that?
I don't, that might be innate. They're, rough grouse are part of, the game birds, pheasants and quail and all that, and, I think something like, it's probably, well, they're not all too smart, let's put it that way. So I think it's pretty much innate, but I'm not sure. I could be wrong.
Woodpecker,
What?
and for the woodpecker, do you think it's innate as well, or is
I don't know.
critical learning period?
I don't know.
Song for-
There might be, I'm not sure. So. Let's see, are we supposed to have a discussion today? Okay, well, let's do that. We don't have much time, so.